Alrighty, guys, back with another one here. Quadratic functions, making it fun. I'm trying to. Uh, but we're going to be converting here between vertex and standard form, okay? Like in this instance, we're given two vertex form equations, and then we're going to convert them to standard. And then in a little bit, I'm going to convert to from the other way, given standard equations, converting them to vertex. Okay. So what do we do? Again, our goal here is to go from this to this. Okay, now how do we do that? Well, vertex, when we're given vertex form equations, it's actually not too bad, okay, because this is almost like an unsimplified version, right? Because there's this squared and there's this a that'll be distributed eventually. But this is standard form is just kind of the straight up, like fully simplified version of a quadratic. So we're just going to kind of just simplify this, solve it out here. But before I do that, let me just explain why. Why do we need to do this? This is one of those things with math. It's like, okay, we're learning it, but I don't really get why. Okay, and with quadratics, again, there's these different forms of them. Okay, the reason there's different forms is because at different times when we're doing different things with the equations, it's advantageous to have them in different forms. Like with graphing, we saw with graphing just last video, having them in this form is super helpful with graphing, okay? And so if it's easier for you, right, instead of having to do that long process, if you could convert a standard form equation into a vertex form equation, then you could graph it really easily, okay? But something else we're going to get into later is solving these quadratic equations, okay? And that vertex form is not very helpful for us. When they're in vertex form, we would actually rather them be in standard form when we go to solve. So again, it's helpful for us to have these quadratics in different forms at different times. So that's why it's worth it to learn to convert from one form to the other, okay? Anyway, let's get into it. So solving this, again, we're just going to like simplify this and carry out all that it's saying here to get it to be in that fully simplified version of a standard form. Okay, so here we go. The first step of doing this is going to be, right, this is saying this group x minus 7 squared, okay? And you would not just go x squared, 7 squared. That's the temptation, it's almost like distribute this exponent. And you would not, okay? You would not do that, okay? You more think of this as x minus 7 times x minus 7. Okay, again, this is saying this group times itself, right? That's what a 2 exponent tells us. Okay, so really that's the more helpful way to think of it is you kind of double or multiply that group times itself. Okay, so then from there, how do I multiply these two groups together? Okay, or something else you could do too before you do that, you could even distribute this too. Okay, but I'd rather do this. I'd rather multiply these two groups together right now. Okay, and how would I do that? Okay, again, my goal is to multiply these two groups together. And I do that through a little process you learned in Algebra 1 called FOIL. Okay, you might remember FOIL. If you don't remember FOIL, so FOIL stands for first, outer, inner, last. Okay, that's the order that I multiply these two groups together in. Okay, so I do the first two terms multiplied. And when I multiply x times x, I get x squared. Okay, and then I multiply the two outer terms. That'd be this x times this 7, or negative 7. So x times negative 7 would be negative 7x. And then I have this guy, negative 7 times x. So negative 7 times x is another negative 7x. And the negative 7 times this, right now, sorry, these are the inner two terms multiplied, and it's the last two terms multiplied. So negative 7 times negative 7, positive 49. And then I combine these two like terms in the middle, right, like I can do with all these FOIL problems, and I would get x squared minus 14x plus 49. Okay, so that is these two groups multiplied. Okay, and then again, I have this 2 that is out front here. That didn't change yet. I didn't distribute that yet. And I have this plus 3 at the end. Okay, so the big math that happens in here is, again, foiling these groups, right, to get this. And then I write order of operations as I multiply. So I multiply these two, this 2 times this whole group. And so you would get 2x squared minus 28x. 2 times 49 is 98 plus 3. Okay, and then my last step here would be to add these like terms, 98 and 3, So I'd get 2x squared minus 28x plus 101. Like the movie 101 Dalmatians, classic. Anyway, so that is the standard form of this vertex form quadratic, okay? So just, again, mathematically solving it out, okay? Again, the order that you do it in is you expand and FOIL this group right in here, okay? Expand and FOIL it to get this, okay? And then you distribute the A term if there is one, and then you would add that K term at the end, okay? And so that's the basic order of doing this, converting to standard form. Okay, let's do one more to make sure we got it, and then we'll go the other way, all right? So for the second one, again, same thing. I look at this. My first step is going to be to expand that squared binomial, the squared group in here, okay? So I'll get y equals negative. And again, it's helpful here. It's just a negative, but I would think of that as a -1, okay? It's not going to write the 1, but that's really what's there, okay? So really that's saying x plus 3 times itself. So x plus 3 times x plus 3 minus 9, okay? And so that again, my steps here, I multiply these two binomials together by FOILing, okay? So first, x times x is x squared. Outer, x times 3 is positive 3x. Inner, 3 times x is another positive 3x. And last, 3 times 3 is 9. So I get that, and I have this minus 9 at the end still, okay? And then I can combine like terms in here. So I get y equals -1 times x squared plus 6x plus 9 minus 9, okay? So I successfully FOILed these two groups into this, okay? And then, just like before, I would distribute this -1, right? So it would be just basically changing all these signs, and they're all positive, so it would be making them all negative. So it would be -x squared minus 6x minus 9, and then another minus 9 from that outside one right there. And then very last step is to combine those two minus 9s. So it'd be -x squared minus 6x, and that would give me a -18. So there is the standard form. And again, I want you to notice something. The A values are going to match each other. Okay, notice the other numbers aren't the same at all, right? 3, 9, -6, -18. But the A values are going to match. Okay, -1, -1, 2, 2. So that's important. That's a good check as well. A small check, but it's still good to check that. Okay. All right, so let me erase these. We will now go the other way from standard form to vertex form. Here we go. We're back, baby. Converting to vertex form, okay? And we're given these standard form equations. And what's tricky here is that, like, I said these are already fully simplified. So, like, there's nothing we can do, like, to these mathematically, like, straight up to solve to get them into vertex form. So we're going to have to do a little bit of trickery, a little bit of stuff here to get it into this form, right? And the key here is that we find the A, H, and K values. And remember from graphing, we said that H comma K is the actual vertex. That's why we call it vertex form. So now when we get into number 3 here, right, what's important, we're not given the H and K values straight up. Again, the A value is going to be the same, but we're given B and C instead. So let's just write down what those are here. Okay, so the A value is going to be 2, the B value is going to be -8, and the C value is +9. Okay, so we're given these values. Okay, so I know my A value of my vertex form is going to match. Okay, but these two values aren't going to be included in the rest of it. Okay, so but we're going to use them. Okay, so the first step is going to be to use that axis of symmetry thing, and what that's going to give me, right? And what I'm talking about is that -b over 2a, that axis of symmetry little formula there. What that's going to give me is the h value, which is good because that's helpful. I need that. Okay, so I do the same thing I did with the graphs. Okay, I do opposite of b or -b, but when it's already negative, okay, so I say positive, right? That's why I say opposite of b. So if it's negative, I make it positive. Over 2a, over 2 times 2, which is 8 over 4. 8 divided by 4 is 2. Okay, so my h value is +2. Okay, so I know that. That's helpful. Okay, and even as you're doing this, what's something that can be helpful too is make like a little template for yourself. Okay, so again, your goal here is to find these A, H, and K values. Okay, again, we already knew A from the beginning. That was 2. It's the same A value as the standard form. What I just found, this also 2, is H. Okay, but keep in mind that it's the standard for it to be a subtraction in here. So I would write x minus 2, okay? But if it was negative, I would change it in here because minus and negative would be plus, right? So I would say x plus whatever, okay? And then for k, how do I find k? Well, that is done by just plugging it in to the original standard form, okay? Because, right, I'm finding the y value of my vertex there, okay? And so plug 2 in there, so I'll get 2 times 2 squared minus 8 times 2 plus 9, okay? So I substitute in that 2, and then I solve it out. So 2 squared is 4. 4 times 2 is 8, so this turns into an 8 right here. Minus 8 times 2 is 16 plus 9. So 8 minus 16 would give me a negative 8. Negative 8 plus 9 would give me a 1. Okay, so I have a positive 1 there. Okay, that's my k value, and I already put it in my template there. So that's my full equation, y equals 2 times x minus 2 squared plus 1. That is my vertex form equation of this. And a great thing you can do to check, as always, my students have access to Desmos, the online calculator, so you can graph this in Desmos, graph this in Desmos. They should match each other exactly. Last one here, I'm going to do number 4, and then we are done-zo. Okay, number 4 says y equals negative x squared plus 10x minus 17. Okay, so again, it's helpful. Write down your a, b, and c values first, because that's our standard form, these 3 coefficients. So a is negative 1, b is b, psych, b is 10, and c is negative 17. So there's my a, b, and c values, okay? So my first step, again, perform that axis of symmetry little formula so I can find my h value, okay? So then I do negative b over 2a, all right? So opposite of b or negative b would be negative 10 over 2 times the a value, 2 times negative 1. So that would be negative 10 over negative 2, which is positive 5. So I just found my h value of positive 5. Love it. All right, and then my step 2 is to plug it back in to here, plug that h value in here to find my k value. So I do that by doing negative 5 squared plus 10 times 5 minus 17. Okay, so negative 5 squared. So 5 squared is 25, but it's negative. The negative is outside. So it's negative 25 plus 10 times 5. So 10 times 5 is 50 minus 17. Okay, so negative 25 plus 50 would be positive 25. And then 25 minus 17 gives me 8. Okay, so my k value here is an 8. All right, and then so we found k, we found h. Where's the a value? There it is. We already knew it from the beginning, right? Don't forget that. The a value is going to be the same. Okay, so my answer, my vertex form of this is putting it all together. Okay, y equals the a value, negative 1, times x in the h value, right? But it's standard for it to be subtracted. So minus 5 squared, then plus the k value, plus 8. There we are. There he is, the vertex form equation of this. So there are some conversions for you. Hope that makes sense. Good times. We are done. Good job. You're the best.